So test for independence. If you guys want to check if two variables are related, they have a relationship or not, you do this kind of test, which is called a chi-square independence test. So this test is used to determine whether there is a relationship between two variables. Oh. Now, the way you state the null and the alternative hypothesis, actually, guys, you're gonna like that. That's how you state the null and the alternative. So he's gonna give you two variables. He's gonna give you the observed values, in a table format, and your HO or HA will be the same statement doesn't change from one exercise to another. HO will be the variables are independent. And can you guess what HA, guys, is?
Dependent?
Yeah. You might see some exercises online that instead of dependent, he put related. So you have to select that word. So any word that is against the complement of independent, you selected right here. Dependent, related, not independent means related. So guys, this is HO and this is HA. That does not change from one problem to another. You start with this statement. So that's the first statement that you have to make. And then step number 2 is to calculate the test statistic, which is the same formula, but we're going to be using technology for this one to calculate the test statistic, chi-square. Then you find the p-value. And then if the p-value is less than alpha, we reject HO. If the p-value is more than alpha, we fail to reject HO. And then, guys, now step number 5, you just write the conclusion in the context of the claim. And same 5 steps. I'm gonna walk you through the steps by doing an exercise, and we'll go from there. So hopefully I'll be able to do a few examples. Okay. I'm gonna leave the first page out. This is where I explain what I'm gonna be doing. And here I explain how to use StatCrunch and the TI-84 calculator. But what I'm gonna start with is just do an example and walk you through the steps, guys, from the example itself. So let's do that. Once you see a table like this, guys, with rows and columns, you know this is an independence test right away. So you can be 99.9% sure that this is gonna be an independence test. A medical researcher is interested in determining if there is a relationship between adults over 50 who exercise regularly and low, moderate, and high blood pressure. A random sample of 236 adults over 50 is selected and the results are given. Test the claim that regular exercise and low, moderate, and high blood pressure are independent. So the variables are independent, and he gave me the name of the variables here: exercising and blood pressure. So I'll just write this as my null hypothesis. So regular exercise and blood pressure and low, I'll just copy it, low, moderate, high blood pressure are independent. And that's the claim, guys. HO. Would the students help me state HA? regular exercise. Probably here you tell me, can we put the variables are independent, the variables are dependent? Well, if you're doing this online, it's not going to say the word variable. It's going to tell you exactly what the variables are. So you just select that. But if it says variables are independent, variables are dependent, just select it. Regular exercise and low, moderate, high blood pressure are what, guys? Are dependent. Okay. So this is the first statement, the null and the alternative hypothesis. Now, if you ask me, guys, why did I state the claim to be in the alternative and in the null hypothesis? Because he says that's the claim that regular exercise and blood pressure are independent. Now, if I ask you to interpret some of the values here, guys, if I tell you what 62 means, it means the total of people who have moderate blood pressure and do regular exercise. If I ask you what 65 means, it's the total number of people who have moderate blood pressure and they do not do any regular exercise. So guys, we wanna see if there is a relationship between walking, exercising regularly for people over the age of 50, and whether this will have an impact on their blood pressure. Maybe you guys, you think that it should because walking is good for you, but these are people over the age of 50. So I don't know. It could have an impact. They could be related and probably they're not related. So we're just gonna study this claim. The next step, guys, is to find the test statistic, which is this. Okay. I do have the observed values. These are the observed values. You'll always be given the observed values. You got the 35, you got the 62, you got the 25, you got the 21, the 65, and the 28. Okay. The expected values, we're going to have the calculator find those expected values for us. So there is no need, guys, to find those expected values prior, just to using technology. All the calculator needs is just to input the observed values, and it will be able to handle the expected values on its own. And I will tell you why in a few minutes. But first of all, guys, I would like to show you how to input this data into the calculator in the same format that it's displayed right here. The calculator needs to know how many have a low blood pressure and do exercise regularly, how many have moderate and do a regular exercise, so on and so forth. So we'll have to display the data exactly as it appears here. And let me show you how to do that. So you're going to have to pay attention to this. This is the first time I'm going to introduce this feature on the calculator. We're going to introduce a feature on the calculator called a table, which is a matrix. They call it a matrix. A matrix has rows and columns. I do have 2 rows of data, guys, and I have 3 columns of data. This is the first row, the second row, first column, second column, and third column. And watch, see how we're going to enter this information to the calculator. I would like you to press the second key right here. And I would like you to press matrix. It's in X inverse right here. And now I would like you to go to edit. So scroll to the right and then enter. And now choose the number of rows and the number of columns. Its number of rows is the first number and the columns is the second one. So I have 2 rows. I just press the number 2 and then I scroll to the next one, which I have 3 columns. Did you notice, guys, how the table has changed? Now it displays 2 rows and 3 columns. And do enter now the given information. 35, enter. 62, enter. 25, enter. 21, enter. 65, enter, 28, enter. Any questions here so far, guys, before I proceed to the next step? That's all you have to do. Just enter the observed values. So let me just quit and do it one more time. So guys, you just go to second, press the second key and press X inverse right here. And then you go to edit right away and then press enter. And you make sure that we need 2 rows and 3 columns. So you make sure that this number is a 2 and the next one is a 3. And then enter the values. Enter them as you see them, as they appear in the table. And then you can quit. And now go to stat, tests. Okay, let me show you where the test is. Scroll up. Okay, we use D. Can you guys guess what is that test for this section, the independence test? I mean, the one who programmed this could have written independence test, but he didn't. Can you see which letter is going to be?
I-squared test.
Yeah,
C.
I-squared test, C, I agree. Take a note, guys. This is for the independence test. Okay. It says observed in A. Don't worry about the expected. The calculator is going to generate them. So just all you need to worry that you have the observed values in matrix A and just hit calculate or draw. Ready? Just do a draw and watch. So chi-square is 3.474. So we used enter values from the table into matrix A. And you've seen that. And the chi-square, guys, turns out to be 3.474. P-value. P-value is the area to the right of the test statistic. So it's 0.1761, which is huge. P-value is more than alpha, guys. Alpha is 0.01. So we fail to reject HO. And then here you can say there is not enough evidence at the 0.01 level of significance to reject the claim that regular exercise, probably this is taking you by surprise. We're saying that we cannot reject the claim that regular exercise and blood pressure are independent, so they have nothing to do with each other. Probably many of you believe that when people walk, that could have a good impact on their blood pressure. It would lower it, but for this one, no, it didn't turn out to be the case. There is not enough evidence to reject the claim that regular exercise and blood pressure are independent. Independent means they have nothing to do with each other. So probably for people over the age of 50, it doesn't matter much whether they do exercise or not, I don't know. And that could be just a bad sample, guys, that we got there. So, but based on what we have, that's the conclusion that we are making. Okay. Now, let me show you, if you want to see the expected values, let me show you the expected values, guys. They've already been generated for you. So I'm gonna clear here and just watch the steps, guys, for the expected values. We already have them. Just press second and matrix X inverse. And I like it to go to B. You already see that B is 2 by 3. It's just like the matrix A. And enter. And these are the expected values. So for the 35, I have a 28.9. For the 62, I have the next one, 65.6, the expected value. And look, the next one is 27.39. And then scroll back and forth. For 21, the expected value is 27.05. Calculator did all of that. 61, and then for 28, the expected value is 25.6. If you don't want to see too many decimals, guys, in your answer and your matrix, look what you can do. Just for now, let me show you. I'm going to go to mode. Let's say I want only to show 2 decimal places. I can just change the settings. But I don't advise you guys to change that. Just leave it at float. Just I'm going to show you now what happens. And then I'm going to go to matrix B one more time. Oops. There you go. You can see a nicer display with 2 decimal places. But if you do that, it just go back and change it to float, because there are times when you do p-value, you need 4 decimal places. Now my calculator is not going to display more than 2 decimal places for anything I do. So just to remember to change it back, so I'm going to go to mode and go to float and leave it right there. So whatever, as many decimals as you can get. Okay, before we do another question, let me tell you how the calculator computed the expected values. So let me just show you. Okay, I'm gonna do some work right here. Just show you how the calculator finds the expected values. It's a lot of work doing it by hand. So, but with this program, the chi-square test, you don't even need to find them. The calculator does everything in the background and will give you the test statistic and the p-value. But in order to find the expected value, guys, just like we did in that chapter on probability, you need to find me the totals here, first of all. So I got 35 plus 62, if students can help us here, 97, and 25, 122. And I think I know what this one here, it's 114 because they add up to 236. And you need the totals from this side as well. So that will be what, guys? 56. And the next one, 62 plus 65, 127. 25 plus 28 is 53. All right. You guys know if 2 events are independent, we learned in chapter 3 that if 2 events are independent, probability of A and B equals probability of A times probability of B. And in a hypothesis test, we assume that the null hypothesis is true until proven otherwise. So we assume that the variables are independent until proven otherwise. If I look at the value 35, guys, this is for low blood pressure and regular exercise. So if I am to find the probability of low and regular exercise, assuming that the events are independent, it will be probability of low blood pressure times probability of regular exercise. Okay, what is the probability of picking someone with low blood pressure? It will be the total of low blood pressure, which is 56, guys, divided by the grand total, which is 236. So it will be 56 divided by 236 times. What is the probability of picking an adult over 50 who exercise regularly? So that's a review for chapter 3. Regularly, guys, I have 122 divided by 236. So this is the probability of selecting someone with low blood pressure and regular exercise will be 56 over 236 times 122 divided by 236. That is the probability. To find the expected value, guys, as I told you in section 10.1, it is n times p. This is the probability, and n is 236. So to find, just the expected value of this value here, 35, I will have to take those two ratios and multiply them by 236. But you're going to see a nice pattern here, which makes it easy to find them. Okay, look, guys, 236 and 236 cancels out. So you get 56 times 122 divided by 236. So this is how I tell students to find the expected values if you're asked to do them. Look, for 35, to find the expected value of 35, look what you do, guys. You find the total of the row that 35 belongs to, which is 122. The total of the columns that 35 belongs to, which is 150, which is 56. You multiply 56 times 122, and you divide by the grand total, which is 236. To find the expected value of 62, guys, look what you do. You find the total of the row that contains 62, which is 122. You find the total of the column that contains 62, which is 127. You multiply 127 times 122 and divide by 236. Let's take, for example, 28. To find the expected value of 28, just take the total of the row that contains 28, which is 114, times total of the column, which is 53, and divide by the grand total. And let's see if this was correct, because I showed you the expected value. So let's do it for 35. Take 122, guys, times 56 divided by 236. Okay, I should get 28.95, guys. Okay, if I don't, then I'm in trouble here. So 122 times 56 just divided by 236. Watch, guys. There you go, 28.95. Just to show you that how the calculator computed the expected value. So if you are to find expected values by hand, you will have to do the totals of each column, the total of each row, and then take the total of the row times the total of the column divided by the grand total, and that should give you the expected values. Okay, but if you're using the calculator using chi-square test, you don't have to worry about it. It's all done in the background. Okay, we're gonna do another one. Example 4. A food services manager for a baseball park wants to know if there is a relationship between gender and the preferred condiment on a hot dog. The following table summarizes the result. Test the hypothesis with a significance level of 10%. Okay, so gender and preferred condiment are what? What's the word, guys? Gender and preferred condiment are, okay, can someone help me with the words here? What do we use here? Independent. And here what? Dependent or related, guys. It's the same thing. Dependent means related. Okay, what does he want? He wants to know if there is a relationship. So what do you guys think the claim is?
Dependent.
Yep. H-O, H-A. The claim is right here, guys. Okay. So input, yes.
Mr. Faz, we are always going to write it like this. First one, independent, second 100%, one,
100%.
Then we choose what he said in the question for the claim.
Exactly. You got it right.
Okay, thank you.
Input table values into how many rows, guys? 1, 2, 3. Oh, total. I don't need the total. That doesn't count as a row, and that doesn't count. You don't need them. So you have 2 rows and 3 columns into a matrix with 2 rows and 3 columns. That doesn't count, guys, as a column because that's you created. You added the totals here. Okay. Let's do this. You ready, guys? So let me show you the steps one more time. That's an opportunity to see how this is done again. So you go to second, and then matrix, which is X inverse. Then you go to edit, and then enter. And luckily I have the 2 by 3, that's what I need. So I don't need to change anything here. Just enter, just put the values, guys. 15, 23, 10, 25, 19, and then 8. That's it. I'm done. Quit. Second and quit. Then go to stat, tests. Let me write down the steps. Chi-square tests. And that's it. You don't do anything there other than just select the test. You want to see a draw here? Let me show you a draw. Slower motion. So chi-square is 2.948 for 3 decimal places. P-value is, let me just move this upward. The p-value, guys, I think it's 0.229. That's huge, which is more than alpha, guys, which is 10%. Fail to reject HO. There is not enough evidence at the 0.10 level of significance to support the claim or to conclude. If you want to use instead of support the word conclude, if you see that in my lab, to conclude that gender and preferred condiment on a hot dog are related. So it doesn't matter if you're a man or woman, that doesn't make a difference when you choose your condiment, just on a hot dog. We don't think they are related. We said there is not enough evidence to support the claim that gender and preferred condiment on a hot dog are related. If you want to know about the degrees of freedom, guys, for chi-square independence test, I'm just going to give you the formula, but you probably won't need it. For goodness of fit test is number of categories -1. Here it is number of rows -1 times number of columns -1. So what would it be for this, guys? What would be the degrees of freedom? Can you tell me? It's number of rows -1 times number of columns -1. How many rows do I have? I have 2 rows, males and females, so 2 minus 1. And how many columns do I have? 1, 2, 3, 3 minus 1. So it would be 2. Degrees of freedom is 2 here. Okay, any questions about this exercise? These are the steps, guys. As you notice, I've been very consistent in the way I state the steps. Excuse me. So this is the independence test. I'm going to show you one more exercise quickly in section 10.3, 10.2 from the book. Okay, here's one. Exercise 21 on page 545, guys. Watch. The contingency table shows a random sample of white, Black, and Hispanic college students based on whether their family borrowed money to pay for their college education. At alpha equals 1%, can you conclude that borrowing money for college and race are related? So borrowing money and race are related. So these are the two variables. The first variable, whether you borrow money or not, and the second variable is your race. We're gonna check if they are related. Okay, let's state this one, guys, and show you how we can complete this exercise. So 21, page 545, number 21. HO, guys, borrowing money and race are not related, are independent. Borrowing money for college and race are independent. I'm being consistent. Whatever we did in the previous exercises, we're doing now. Borrowing money for college and race are dependent, which is the claim. Correct, guys, because it says related. Related means dependent. Okay, so we're gonna input table values into matrix A. Okay, what is the matrix here? I have 3 rows and 2 columns. So 3 rows, 2 columns. Okay, let's do that first. And tomorrow when we review for the final exam, guys, through the review exercises, I'll show you how to use a StatCrunch for this. I won't have time, just to do it today, but you got the instructions in the sheet, but I will demo that tomorrow. So we're just gonna go to second, X inverse, edit. Okay, and we need 3 rows, guys, and 2 columns. And just enter the data. 49, 64, 85. What do you guys think? There is a relationship between race and whether people borrow money? Probably. And this is an issue of equity now here. 85, 180. Okay, I'm done. You just now go to stat, tests, chi-square test, guys. That's the test. Okay, AB. Let me hit the draw and show you the results. Again, it's a right scoot test, as you can see, guys. So chi-square is 5.994 and p-value is 0.0, at the 1% level of significance. So chi-square test, chi-square is, again, guys, let me just show you the values. 5.994 p-value. Let me just show it again. 0.0499, which is bigger than alpha. Fail to reject HO. At alpha 5%, we will reject HO, but at 1%, no. There is not enough evidence. At the 1% level of significance to conclude that race and borrowing money for college are related. However, guys, at the 5% level of significance, you would say that they are related. Okay, so that concludes section 10.3. I'm gonna jump, guys, to section 10.4 in the last few minutes. That's a very easy section, and should take me a few minutes, just to cover this section. Okay, you learn, guys, in chapter 7 how to compare a mean against one value. In chapter 8, you could learn how to compare two means, mu1 and mu2. But what about if we want to compare more than two means, like 3 means, 4 means, 4 population means, 5 population means, 6 population means? Chapter 8, just what we learned in chapter 8 would not work for us because we only can use it to compare two means. For example, let's say someone makes a claim that a certain toothpaste, just has different prices at Walgreens. Walgreens is Walgreens, but you go to different places in different cities in Michigan, and you suspect that the price, just is not the same. So you want to just make a claim, or you want to test whether the average price, just of this particular toothpaste, is the same, at all Walgreens, just stores. So what you do, you select the 3 or 4 stores. You go to the first store and check on the prices. You pick, a sample, just of this toothpaste and check on the prices. Then you go to the second store. Then you go to a third store, probably a fourth, and then you can test the claim whether you think that the price is the same or is not the same. So when there is a test that involves more than two means, you would have to run what we called one-way analysis of variance, which is called ANOVA. And actually, it is the last test on your calculator, guys. And to state the null and the alternative hypotheses, this is probably the easiest way test when it comes to stating the null and the alternative. The null hypothesis will be always that all the means are equal, guys. And your alternative hypothesis will always be at least one of the means is different from the others. These two statements do not change from one problem to another. You always select those two statements. Now, the assumption of the test. The first assumption of the test, each sample must be randomly selected. Must be randomly selected. Always in good statistics, sample must be randomly selected from normal distributions. So population has to be bell shapes. That's condition number 1. Condition number 2, the samples are independent. And when you go to 2 different Walgreens locations, you're getting 2 independent samples from 2 different places, guys. And each population must have the same variance. These are the conditions of the test. In order to run this test, guys, we're gonna run a distribution called F distribution. That's the last one. So you learned about T, you learned about Z, you learned about chi-square, and the very last distribution, it's called the F distribution. And let me show you the F distribution in action from the book. I'm just going to show it to you, and then we're going to use the calculator to do one exercise. Okay, this is what the F distribution looks like. It's a kind of scoot to the right. This is the F distribution. It's a family of curves. It has 2 degrees of freedom. One, it's called the numerator degrees of freedom, and one is called degrees of freedom of denominator. It is positively skewed to the right. It's always greater than 0. Total area under the curve, guys, is always equal to 100%. So this is the F distribution that we're going to be using. But all you need to worry about, guys, is just figure out how the calculator can find the test statistic for you. Your test statistic in this case is not called T, it's not called Z, it's not called chi-square here, it is called F. And that's what the test statistic is going to be like. So I'm going to take you to an exercise, guys, right away and show you how we can perform the ANOVA test. Usually, actually, students find it when they have a question like that, they think that it's a freebie question because it's so easy, you know, just to process and work out. So let me just do this example and then we'll stop there. A medical researcher wishes to try 3 different techniques to lower cholesterol levels of patients with high cholesterol levels. The subjects are randomly selected and assigned to one of the 3 groups. Group 1 is given medication, group 2 is given exercise program, and group 3 is assigned to diet program. At the end of 6 weeks, each subject cholesterol level is recorded. Test the hypothesis that there is no difference among the means. Okay, you start. When you see 3 groups, guys, you know this is an ANOVA test. You start with HO, mu1 equals mu2 equals mu3. I'm not going to go further because I have 1, 2, 3, so I stop at 3. Does anyone still remember what HA was, guys? It's the exact statement that I showed you. At least one of the means is different from the others. That's what you select, guys, when you do this work online. Now, guys, can you tell me where the claim is? Test the hypothesis that there is no difference among the means.
Joe?
Yep. No difference means equal. Okay, ANOVA test. And let me show you how to run the test. In order to run the test, input the data in L1, L2, and L3, guys. And actually, it is by far the easiest test to run once you input the data in there. I'll show you in a second. Stat edit, clear, and L3. Okay, let me just put the data 11, 12, 13, 15, 9, and 8. Second, L2. 835240. Next, L3. All right, and I'm ready to run the test. Stat, test. It's a last test, guys, ANOVA. Any guesses? What do I enter here?
Second, 1.
You got it. ANOVA. Second one, which is L1, and then comma, L2, comma, L3. That's why I said that's a very easy test to perform. So second, 1, comma, second 2, comma, second 3, and we're gonna get the test statistic and the p-value, guys. Watch. The first value is the F statistic, which is called the test statistic, 11.09. P-value is 0.0011, which is less than alpha. We reject HO, and we say there is enough evidence at the 0.05 level of significance to reject the claim. So that means the means are not the same, they are different. So, and that is ANOVA test.